Hi class, this is number 7 in 12.5. The following table shows retail sales in drugstores in billions of dollars in the US for years since 1995. So note that is this value year, that is the years since 1995. It just makes our independent variable here a little more simpler, so we're not have all these large numbers. And this number is also has been simplified because this is actually doesn't mean 85. There wasn't $85 of sales, retail sales. It was $85 billion of sales. So this is in billions. So we have to remember that when we're throughout doing this problem. Whenever we're plugging something at X value in, we have to first translate it into the number of years since 1995. And also, when we are plugging in a Y value, we also have to write it in billions as well. Okay. But anyways, so they say let S of T be the retail sales in billions of dollars in years in T years since 1995. A linear model is F of T. I think they really need S of T, but whatever. F of T equals 9.44 T plus 84.182, and they actually have drawn the scatter plot with the least squares regression line drawn over it here, and says use the above scatter plot to decide whether the linear model fits the data well. I would say for sure. It looks like almost all the points lie exactly on the line. So I would say the function is a good model for sure. And then estimate the retail sales in US in 2012. So they're giving us a year, which means they're giving us an X value. We want to plug in the X value in to this equation and then find, or the X value, T value, T, X or T value, and then find the given F of T or Y value. So that's the first thing that we're going to do in this first part. So first I have to translate 2012. How many years after 1995 is that? So I do 2012 minus 1995. And I borrow from the 1, that's 12, 7. And then I borrow from the 2. Why did I not line things up? I don't know why. 1, and then I borrow from, ooh, careful. I have it all. Oh dear, I'll just do the calculator. 212 minus 19. It says you have to make sure to line up each number underneath the other one above it. So borrow from the 1, get 12, and then now I can't do 0 minus 9, so I borrow from the 2 here, get a 1, and then 9 and 1. So it's 17. 17 is our number. And there's 0 zeros. Okay. So this really means when X equals 17 or T equals 17, in this case, the independent variable is what we usually call our X variable is 17. And they want us to write the number, though, let's find the Y value or the F of T. So I plug in 17 for the T. And I always put, whenever I plug something in, I put it in parentheses. And actually I was doing this on my calculator and my cell phone calculator, and I actually noticed that the calculator is a little like weird. It tries to do algebraic steps. And so sometimes I make it do just one thing at a time sometimes, and sometimes that works a little better. But I do 9.4, it actually tries to do, order operations for you. but it also displays the answer at the same time, so it's a little weird. So you might want to put parentheses in just to make sure that it's giving you the answer that you want. I'm going to put 9.44 times 17, and then in parentheses plus the 84.182, and I get this 244.6. So let's see how they like that answer. And notice how we do not have to, I mean, we're getting 244.6, but that is in billions. So if they wanted us to ask, if they're asking in dollar bills, we would have to do 244.6 times, 1 billion, but to actually get the number of dollars. But they actually want the answer in billions, so we don't have to do anything to it. We just, and the 244 to round it to 245, is their answer, and we're fine. And they don't give us the number of decimal places, but I believe if you put it in 244, that if you get within one of the actual answer, I believe, probably give this answer to you. Yeah, so they have it. I just put my answer in and accurate to any decimal places. It looks like it will get it correctly as long as it's within one of the actual answer, I believe. But okay. Use the model to predict, now let's go to the second part. Use the model to predict the year. So now they're asking the year in which retail sales will be 230. Well, retail sales, look back up, retail sales is a second variable here. And that is the Y variable. So we need to plug retail, we need to put that number in for the F of T instead of like we plugged in the 17 for the X and found F of T. Now we're going to plug the given number in for the F of T and find the X. So instead, we're going to put the 230, and notice it's 230 in billions, and our Y and the Y value is in billions, so that matches up, and that's fine. So I put 230 in for the F of T equals 9.44 T plus 84.182, and then subtracting 84.182 from both sides. And so let me do that on my calculator and give the answer. So I get 145.818 equals the 9.44 T. And now be careful. What I did is I just put divide by, because it gives you the answer, but you actually have to kind of press equals. I didn't press equals, and that's confusing with your cell phone calculator when you're doing calculations. Until it's presenting you the answer, so you think you pressed equals and you think it's done, but until you press equals, it's going to think it's one long algebraic expression, and you try to apply order of operations and you may get it wrong. So that's what I was doing before. Like I entered in my calculator 230 minus 84.182, and then I did this next step, divide by 944 on both sides. So I told the calculator, oh, divide by 944. Well, the calculator did order of operations, and it did 84 divided by 9.4, and then took 230 and subtracted that answer from it. So because I didn't press equals, but it's confusing because I thought I pressed equals because it's showing me the answer already. But so just be aware of that. So I would do this calculation, and just to make sure that it's doing that first, you press equals, then press divide by 9.44. So now divide by 9.44, and I get 15.44. we rounded to 15. Now, one little extra step here. So if our X is equal to 15, they actually want the year and not the years after 1995, because the X values are years after 1995. So I have to take 1995 and I have to add 15 years. So that is 10, 11. So 2010. And that's what we get, 2010. So be careful there, you know, to like remember your X values when you solve for X, that X is the years after 1995, not the actual, you know, year that we recognize as, you know, 2010 or not. So make sure to make that extra step. Next step. All right. Well, let me know if you have any more questions. Have a good day. Bye.